Today, we are diving into a practical and essential network configuration task, setting up a network with both data and voice virtual local area networks. By the end of this, you'll understand how to configure switch ports, trunking, configuration of sub interfaces, DHCP pools, telephony service, and extensions for IP phones. Let's get started.
Step 1. Topology Design. Drag and drop the following devices on the workspace. 1 Cisco routers, 1 Cisco switch, 10 PCs, and 10 IP phones. Arrange the devices visually. Place a router, a switch, 5 PCs, and 5 earphones on the left side, and repeat the setup on the right side. Connect the router to switch in the left and right side. Use a copper straight-through cable to connect. Router fast Ethernet 0/0 to switch fast Ethernet 0/1 on the both sides. Connect switch to the PCs and earphones in the left and right side. Use a copper straight-through cable to connect. A layer 17BC switch where all devices are connected. A router that handles inter-VLAN communication. IP phones connected to the switch with some phones sharing ports with PCs, and of course the devices themselves, PCs for data and IP phones for voice.
Now let's start configuring the switch ports. When a port is connected to an IP phone and a PC, it must handle both data and voice traffic. The data traffic uses VLAN 10 and the voice traffic uses VLAN 20. Switch port mode access. Switch port access VLAN 10. Switch port voice VLAN 20.
Step 3. Configuring the trunk port to the router. Next, we configure the trunk port. The link between the switch and the router must be a trunk to carry traffic for both VLANs. Switch port mode trunk. This tells the switch to tag traffic with VLAN IDs using the 802.1q protocol. Now, the trunk is ready to send VLAN tagged traffic to the router.
Step 4. Configuring router sub-interfaces. The router needs sub-interfaces for each VLAN. Sub-interfaces allow the router to route traffic between VLANs. Interface Gigabit Ethernet 00.20. Encapsulation .1Q20. Interface Gigabit Ethernet 00.10. Encapsulation .1Q10. For VLAN 10 data, the encapsulation .1Q10 command binds the subinterface to VLAN 10. The IP address 192.168.10.1 acts as the default gateway for this VLAN. We repeat the same for VLAN 20, but with a different VLAN ID and IP subnet. Now, the router can route traffic between VLANs.
Now, configure DHCP pools to automatically assign IP addresses to devices in each VLAN. This is done on the router. IP DHCP pool data. Network of 192.168.10.0 and 255.255.2550. Default router 192.168.10.1.
To telephone services. Telephone service. Max ePhones 10. Max DN 10. IP source address. Port 2000. Auto assign 1 to 10.
Step 7. Allocating dial numbers or extensions to phones. Finally, we assign extensions to phones manually or automatically. ePhone-DN1, number 1001. ePhone-DN2, number 1002. Each ePhone-DN corresponds to a phone. We assign the extension number with number and associate a name for clarity.
And that's it! We've covered every step from topology design to configuring VLANs, trunks, router sub-interfaces, DHCP pools, telephony services, and extensions. Your network is now ready to handle both data and voice traffic efficiently. If you found this helpful, feel free to try it out in a lab environment or reach out with any questions. Happy configuring!